useful in finding the slope of a tangent line at a certain point of a function. How are ya? The traditional way of finding the derivative of a function, when it is composed of a composition of functions, is like so.
I'm fine. If you have a polynomial like y equals 2x plus 4 squared, well, you get the polynomial when you square it, and you get 2x plus 4 times 2x plus 4. And when you FOIL, you get y equals 4.
Fantastic 4.
4x squared plus 16x plus 16. Then to find the derivative of this polynomial, you do 2 times 4, which is 8x, and then 2 minus 1 is just 1, so you can leave it, and then plus 16. And that is the standard way of finding a derivative for a polynomial.
Because this method of FOILing takes so long and could take even longer when dealing with larger exponents, the chain rule is used. The chain rule is useful when one wants to find the derivative quickly of a function, which is a composition of functions. The chain rule is used by finding the derivative of the outermost function in the composition and working your way in.
So you would use the chain rule. The chain rule is when you have an equation where y equals f of g of x, then the derivative, or y prime, is equal to f prime of g of x times g prime of x. So when you have an equation like we were using before, where y is equal to 2x plus 4 squared, you want to find the outermost part of the equation, which would be the square. So normally when you have a square, you bring down the 2 to the front and you subtract 1 from the top. So that would be f prime, we putting the 2 in front. Then g of x is the more inner part of the equation, so gx is this, which we put here, which would be 2x plus 4, and then since we're calling this g of x, g prime is just equal to 2, so we do times 2. And then this whole thing you would do, would come out, when simplified, would come out to be 8x plus 16, which is the same thing that we got before. This is just a simpler way of doing it so that you don't have to FOIL.
Go.
So here's an example of another equation where using the chain rule is really helpful because FOILing would take way too long. So if you have an equation where y equals 2x plus 6 to the, let's say, 7, it would take a really long time to FOIL that all out. So using the chain rule, you can find that f prime, the outermost part of the function, is the exponent of 7. So you get y prime equals, and you bring the 7 down, and then subtract 1 from here, and you get 8. You get 6. And then we're calling this g of x up here, so we can put in 2x plus 6. And then g prime, so the derivative of this part, we multiply the whole problem by, which is just 2. And then you would simplify by putting the 2 in front, so you get 14, 2x plus 6 to the 6. So then you could simplify this a little bit more, but that is pretty much the derivative, and that took a lot less time than it would have to FOIL out the whole original problem.
Now we got ourselves a nice product rule over here. So, product rule. Glad we got that established. So, let's say we have a problem, something like this, where it's 2x times 3x. And we were asked to take the derivative of that. It wouldn't be hard, because all we have to do is multiply these together to get 6x squared, and then take the derivative of that, which is 12x. That's not very hard, and that's how we began this process. However, there is a time where you do get many complex functions where you can't just solve it that way. So through lots of practice and noticing patterns, we were able to come up with something called the product rule, which is essentially, this is how you do it. This is an example of a problem that you could not just do it the traditional way of solving it. You have to use the product rule. So what you do in the product rule is you take the first part, find its derivative, which is 2. In this part, you find its derivative as well, which is cosine x, cosine of x. And what you do with these two derivatives is you crisscross them. You multiply this by this and this by this. So you get, and then you add and then you take these two and add them together. So let me show you what you do. 2 plus these two things. So you couldn't have solved this derivative with using the old-fashioned way. This is the only way that we would know how to do it. But to get more specific, the actual formula for the product rule is this. We just showed you how to do it. This is the actual formula. Y equals f of x times g of x. So the derivative of this using the product rule would be y prime equals f prime of x times g of x plus g prime of x times f of x. So that's the actual formula. No.
Sorry. Thanks.
Special thanks to this store right here who videotaped everything. How are ya? How are you at Starbucks?
Okay, no, don't say that.
How are you at Starbucks? Alright, stop. F of x. No.
F of x over g of x. Over g of x. I promised you it's over g of x.
Over g of x squared.
No, and then y equals f of x over g of x. So then the derivative y equals.
What are you talking about? And we got to this equation. Close that door. Gosh darn it. Yeah, what's Bud with?
I'll close it.
Mr. Yo!
Just 1 second.
Mr. Yo, turn it up. Now, in here?
Okay.
Alright, 2 seconds. Alright, so, now we...